Welcome back everyone to the Hello World Guide. This is another episode of the Advanced Platformer series, and if you remember, in the last video we created different kind of animation clips for our like this character that we have got here, and that's all pretty awesome. But in this video we are going to create an animator system and figure out a way to kind of make it so that our player displays the correct animation at the correct time. Now in the animations folder, Unity automatically created an animator for us, which it calls sprite. Since we had got it on the sprite object here, I changed the name to player so that it makes a bit more sense here. And you can see we have got the animator object component on the sprite. Unity automatically added it, and of course the controller is this player, and that's pretty much it. And if I go under player right now, currently of course we do not change anything, and if I open up this animator, you can see by default I have made it say the idle animation. By default it was run, so if you right click and say set as layer default state, it will start displaying the run animation, but I want it to begin with idle, so I'll set that as the default. Now this means that when our player starts, it will start at the idle animation, and we can create more transitions to kind of go under animations. And since this is like not really a beginner series, I'm not going to explain every single step, but we are gonna get over it a bit quickly, because it's not like a really advanced kind of thing. So what I'm going to do is I'm going to select the this animation here that we have got, and now what I'm going to do is I'm going to go ahead and you can see we have got like run here and idle here as well. Now we are going to remove this exit time, because we do not want it to move when the idle animation has finished, of course. And I'm also going to make the transition duration be 0. We want the transition to be instant, or you can perhaps remove the fixed duration and set that to 1. I don't know, maybe 100%, but we are going to set it to 0 anyways, and because we want the transition to be completely instant. And what we are going to do is, you can see that it does not have any condition. We'll need to have a condition here. However, the problem is that there is currently no other conditions, so we are going under parameters here and add in a float parameter called speed, and we'll add a condition here saying that speed is greater than 0.1, then we'll switch to run. However, if the speed is less than 0.1, then we'll switch back to idle. So we'll switch back to idle. We will remove exit time, and we'll also remove the duration we have got. Instead, what we'll do is we'll add a condition, and it will happen when the speed is less than 0.1. If the speed is greater than 0.1, then then we are going to go to run, and if it's less than 0.1, we are going to go back to idle. That's the only thing we are going to keep right now. We are going to not worry about any jumping right now. Let's just go ahead and try to get this done, and let's just clear all of that. And the thing is that it says the difference in effective length between the states is too big. We are going to set the exit time to be 0 as well, and just go ahead and clear this. It's still giving it. So yeah, we have got that, and it works. So what we are going to do is, now we are going to go ahead and open up our script slash movement. So I'm going to open up my movement script inside of Visual Studio, and let me zoom in a bit here so that you can see stuff a bit better. And you can see we have got all of these variables. We are going to add a serialize field. We are going to add another reference, but this time it will not be to this, but it will be to like an animator. So we can set the variables on the animator directly. So we'll have a private animator here, and not an animation, by the way. An animation is a different thing which we created in the last video. We'll want an animator. So we'll have the animator, and what we'll do is we'll basically go ahead and say let's just say animator dot set let's say set float. There are a bunch of different methods for setting different kinds of values. We'll set a float, and the float we'll set is going to be well, for the name of the float it's going to be speed, and for the actual value what we'll do is we'll say animator dot, actually not animator, we'll say our velocity, but we won't pass the velocity directly, because if we pass the velocity directly, then it will cause a very obvious problem, which is that when we move back it will not display the running animation. Instead, what we'll do is we'll use math f dot absolute, and that would help us get the absolute value. The reason we want to do this is because this would allow us to get like the actual positive value. Even if it's negative, it will convert it to positive, so that we get the actual speed and not whether it's forward or backwards. And now if I go ahead and compile that, you can see that it's basically compiling everything. And we are of course going to make sure that we select our player and assign the animator, the sprite animator here. And once we have done that, now we should be able to run and everything should work perfectly. So you can see it's compiling, and now it runs. And if I move left, you can see it started displaying the animation. If I move right, it started displaying the animation as well. But the problem right now is pretty obvious, which is that if we move back, then the character does not turn to face that direction, but instead the character keeps looking at the forward direction. So we want to of course make it so that the character turns to face the direction that is going in. So we are going to say if velocity dot x is greater than velocity dot x is greater than 0, not actually 0, let's just make it 0.1f. And what we are going to do is we are going to go ahead and say animator, whatever animator we have got, dot transform, and this would allow us to get the transform of the object. And then we'll say dot local scale, and we'll say dot x. And you might say that we can just say x multiplies by, for example, -1. Well, actually we won't be able to do that, because if we do that, it will just invert it. We'll just set the x to be -1. However, you can see that does not work, because local scale is not, it's not a variable, it's a property, so we can't modify its value. So what we'll have to do is we'll have to go ahead and let me just remove this, and we are going to add some braces here. And now we are going to paste this thing we have got here, and we are going to store this value in like that. So we'll create like a vector 3 called let's just call it scale, and set that equal to whatever we have got here. Now then we are now what we are going to do is we are going to say scale dot x is equal to we want this to be negative. So like if we are facing to the right, then we want to invert it. If we are already facing to the left, then we don't want to invert it. So what we want to do is we might want to create like a private boolean here, private bool called let's just call it for example is facing left. So is facing, or you can make it is facing right or is facing left. By default we won't be facing left, so we are going to set that to false. And what we'll do is if our speed is greater than 1 and we are facing left as well, which means that we are facing left while we are moving towards the right, then we are going to take the scale and just invert it x value. And in the end we are going to go ahead and say animator dot transform dot local scale is equal to the scale that we have got. Local scale is equal to this scale variable that we have got. Now if the situation is inverted, which means that the velocity, we are going to say else, and if the velocity is less than -0.1f, which means we are moving towards the left and we are not facing left, which means we are moving towards the left while we are facing right, then we are also going to do this thing. So let's go ahead in here, and we need to make sure that we actually save this. And now let's go back in here, and it should compile it automatically. And now when we run this, you should see that our player automatically turns to face the direction that we are moving in. So we are going to let it compile, and then we are going to run this, and what you should see is that everything does indeed work. So you can see that we can move towards the right, it's correctly, and if I turn towards the left, it kind of turns, but then it starts to do this. So why does it do that? So as soon as that happens, you can see it's kind of starts to do everything wrongly. So it starts to kind of madly change its direction. That only happens when it is our velocity is less than -1. And if our velocity is less than -0.1 and we are not facing left, then we are the reason this is happening is because we are not actually setting the facing left variable correctly. So if this is the case, then we want to make sure we set is facing left to false, and if this is the case, then we want to make sure we set the is facing left to actually true, not false. So we need to set it to true, and that should fix our problem. And of course we want to save this as well, and save that, go to Unity and let it compile. And now it should automatically know which direction we are already facing it, and we should be able to set it correctly. The reason we just couldn't set it to -1 or +1 was because it's the scale might not exactly be 1, and that could cause a bunch of problems. So let's just do it this way. and you can see if I move right it works, and if I move left, well, it's still kind of shaky. Did not seem that it actually changed what it was supposed to do. So when we are oh, actually we kind of made it in a wrong manner. So if we are moving, we want to set it to true when we are moving towards the left, and set it to false when we are moving towards the right. So when the velocity is negative, then we are moving towards left. So let's go ahead and try that again, and hopefully this should work this time around, and it should compile everything. And now I'm going to run this, and now what you should see is that our character does indeed look in the direction that it's moving in. So you can see if I move right it works, if I move left it works as well, and I can change my direction at any time, and it's working like a charm. And of course our animation also displays correctly depending on what we are doing right now. And in the animated state, you have got, as you can see, we have got on two of these here. So one is going from here to here, and the other is basically the opposite of it. So yeah, it's pretty much working, and that is all pretty awesome. So yeah, that's cool. And the next thing that we want to do is we want to kind of figure out a way to incorporate jumping in here as well, so that we can go from jump to idle and run to jump and all of that. So we'll have to basically have a triangle here. So in here currently you can see we have got speed, and that is 0 currently. And what we are going to do is we are also going to add a bool, which is going to be we just call it is grounded. So the reason we are having this boolean here is because whenever we are not grounded, we want to display this jump animation. So in here you can see we have got run here, and we don't have like separate jump and fall animation, so we can just make it a lot simpler. So we are going to move from run to jump, and from jump back to run. But when we do this, we are going to of course set this to 0 and 0, and remove exit time as well. And then what we are going to do is we are going to add this here, and the condition is going to be is grounded. So when is grounded is true, actually not true. When it's false, then we are going to move to jump. Now in here we are going to basically do the opposite thing. We are going to set back everything to 0, and we are going to add another one. If the is grounded is true, then we are going to move to run. However, there is an other condition that we will add here, which means that speed is also greater than 0.1. If the speed is greater than 0.1, then we'll move to jump. If the speed is less than 0.1, then we'll actually move back to idle instead of moving to jump. So we'll select this, and let me just select this to 0, and also remove exit time here. And it's going to move if the speed is less than 0.1 and is grounded is true. So we are going to also check if is grounded is true. And of course we'll need to create a transition from idle to jump as well, and this is not going to have any of that time either, and transition duration is again going to be 0. And when we move from idle to jump, we want to ensure that we first of all the speed is well, we're going to add two conditions here. Well, let's just make it one condition. Is grounded is false. If is grounded is false when we are in idle, then we are going to move to jump. If it's false when you are in run, we are going to move to jump as well. But moving back is determined whether on speed or not. And in here what we can do is, you can see if our contacts are greater than or equal to greater than 0, well, basically that means that we are grounded, and then we are going to set this. And of course what we can do is we can also just set an animator variable here. So we are going to do animator dot set bool, and the boolean that we are going to set is going to be is grounded, and we'll just set that to true. Now you might be saying, okay, and we can set it to false when the contacts are less than 0, but we won't actually do that. Instead what we'll do is let me just go ahead and copy this line that we have got here, and I'm going to Control Z. We are going to keep this simple, and we can do it in a much more concise manner by just going ahead and saying set the is grounded to whether ground check is greater than 0 or not. So we can just say ground check dot contacts is greater than 0. We can just pass that as a boolean correctly, because this expression is after all a boolean. That I forgot to show in the last video was that you need to make sure that you actually position your ground check down where it's actually supposed to be as well, and scale it correctly as well, and just make sure that it's at the correct position, at location, at everything, because if it's not, it could cause problem, because our previous ground check was at the wrong position compared to this model. So we are going to set it to 0.01 at the location. You can just kind of fine tune the location until you find something you like, and just make sure that it's actually at the ground and not somewhere else. So yeah, make sure that it's actually at the ground. So after you have made sure that this is at the right place and every variable is set correctly, let's just go ahead and run this and see what happens. So what you should see is that by default it starts in the jump animation, because well, obviously the player is kind of off ground right now, and once it reaches the ground it goes back to this. So I can go here, and as soon as I jump I go back to that animation, and I can jump around and every animation seems to be working correctly. So yeah guys, that is pretty awesome, and you can see that our character is animated, and it's displaying the correct animation at the correct place. So yeah, this is pretty much it for this video. I'll see you in the next one, in which we'll go ahead and implement implementing some actual stuff for our game, and maybe implementing like a tile map system. So stay tuned for that, and make sure to like and subscribe so you don't miss that, and share this video with other people as well, and bye.